Hello everyone and welcome back to my tutorial. Today we're gonna talk about again the Rhino and Rhino.Inside, how you can create a workflow between these programs, between Revit and Rhino, and how these programs will help you, for example, in your daily life work. For example, here I need to create something like egg shape inside of my building. We can do the simple form in Revit. You can check the previous my video. I already did it by Dynamo and other different ways. But in this way, I will show you how you can do the workflow between the Rhino and Revit inside your project. And after that, we will gonna get our simple script. Yeah, it's quite long as you can see, but it's simple. You will see it. You will get the shape, and it automatically will import inside to our Revit project. So if you are ready to this tutorial, let's get started. Okay, here's my shape. As you can see, here's everything internal. We can see everything what will be inside, like a frame, walls and doors, everything else. But we should create the cover. How we can do that? As you can see, we have some references here. We have some lines. We can use these lines as a reference. If we will look the right side, we can see, for example, I will show you this part like here and this part like here. It's not equal by height, but it's not a big problem for us because we can, for example, take this side on this side, and in Rhino we can move it to the a bit above, or we can move it a bit down, so it doesn't matter. We just need a reference where our object will be located. That's it. So let me I will see what I have here. As you can see here, I have some reference line like this one, and let's use this reference line and place our object. So for that one, we can now ready to move the Rhino inside. Let me will start my Rhino, and we will import this line inside to the Rhino. So once it's Rhino will open, I will back. So Rhino is here. As you can see, we just switching on our Rhino. Actually, we will do everything in Grasshopper. Here I will just change my type view to the maximize 3D view, and I will switch on the Grasshopper. Let me go back to the Revit. Here's the Grasshopper, left click, and Grasshopper is starting. Okay, so we're gonna work in Grasshopper in this tutorial much more than in Rhino. First of all, we need to take our geometry. We should take this line as a reference. For that one, we need the graphical element. Let me will use the graphical element. Right click on the graphical element and say set multiply graphical elements. And let's choose this line like 1 and 2 as a reference. Once you will finish, just click button finish. And here we are. We cannot see anything here because now the magic is going on Rhino. So let me will place here the window, and I will go back, and now finally you can see our shape, and as you can see, it's where it's locating. It's not a bit, it's really far from the 0 point. Okay, once we will do that, now we should get kind of the points. We should divide our cycle to the two different points. To divide it, we need use the divide. Let's use divide. So it's here, divide curve. Let's connect our element. And as you can see, now we can see the points on our curve. But we need only the two numbers. Let me will write here the 1, and let's connect to the number. And now you can see only two numbers. So after that we need just P line. Sorry, it's my mistake. P line. We will create our polyline from our vertices, from our points, and as you can see, here is our points. Why we need that? Actually, we need these lines only for the one thing. We need to get the midpoint. So here is the curve middle, and by this curve middle we can get the midpoint, and we will know exactly where is our middle point for this cycle. This one we can right click, select it, right click on the screen and preview off. And now you can see here's your midpoint and here's your graphical element. So by these two simple things we already created. Now we have our middle point, and now we need to create the sphere, because we need now create the shape of our future egg. For that one we need the sphere. So let's use the sphere. It's here. And let's connect our midpoint to the base point. And now we need the radius. Radius, let's say it's 17,000 millimeter, and let's connect to the radius. We get something like that. Better to switch now to the all this kind of, let me do like this. I wanna to the whole screens, and now we can see exactly where is our line and exactly where is our sphere. So we need to get the same distance. 17,000 it's not enough. I think it's 17,200. So let me do, and as you can see it's exactly 17,200 millimeter. So we did it. So the next thing, we need a bit scale it on this side. Always on this side we just need to scale it. So we not we should create something like an ellipse. As you can see, it's more like an ellipse. To scale it, not just like a 3D, we need to use the scale by N and U. So this is mean we will use only some of the axes. Here is our sphere. Sphere is geometry. Let's connect sphere to the geometry. We did it. I will select this sphere and right click and preview off. I wanna see only the final result. And now we need to change only the scale of X and Z direction. Let's start from the X direction. We will start from the 2.0. 2.0, don't forget the 0.0, and by this way you will get a not integer number, you will get the float number, which is help you to get not just two exactly number, 2.1, 2.3, so float number it's with the point. And let's connect to the X. And as you can see, it's it's totally changing distance, so this is not what I want. As you can see, it's a really bad thing, because the reason our plane is different. To make it the same plane, we should connect our midpoint to the plane, and as you can see now it's exactly on this point, and we can now control it. So I will try to change it a bit scale down, and as you can see it's something close with this result. So maybe it's not 0.3, maybe it's 0.300 like this. Let's say okay. It's not working. Why? Because we have only digit after the point, only one. We will do like 3, why not? And now we can change like 3 here. And as you can see now it's exactly on the point. And we get exactly the shape what I want. But it's not finished, because if we will go back to the Revit right now, yes, now it's matter to going back to the Revit, you will see our egg is actually really big. It's going out of the range. So we should make it smaller. For this thing we should change the Z direction, so we should make it a bit smaller from this side and from this side to make it till here, for example. And this is really nice feature when you're using the Rhino.Inside, because you can see it's not only Rhino, you can see your future result also in Revit, and it really helps you. So let's back to the Rhino. Actually we should go back to the Grasshopper. I will copy this scale slider, and I will copy it to the Z direction. Let's use the Z direction, and as you can see it's now much bigger, because if you will choosing the number more than 1, it may becoming bigger. If you're using the number less than 1, it's coming the less, as you can see. So I will start from the 0.8, and let's go back to the Revit. Yeah, it's hard to control everything because we have a lot of the windows, but if you have the big screen, I don't think so it's big problem. I will go back, and as you can see 8 0.8 is really close, but not enough. We should make it a bit much bigger, a bit thicker. Let me, I'll go back to the grasshopper again, and let's make it 0.5 of 85. Let me try it. It's much closer. Maybe 9 will be nice. Let me, I will make it 9. 9, and let's say okay. And now it's becoming much bigger. And yes, now we're covering everything. Don't afraid about, for example, this situation, because we will make now we have only the surface which is outlier line, and we also will create some offset of that. So it means we will cover all these things, so it's not big problem. Let me go back to the grasshopper again. Here we are in grasshopper. Now we need to move it. Why we should move it? If we will go back, you can see our midpoint. It's here. Let me, I will go to the right. It's not right side right now, because it's here, but we should make it a bit up, because now it's so lower. I need change position. Let me, I will a bit extrude it. Now you can see better. Yeah, it's here. I think it should be somewhere here. Let me move it, or we can leave it as it is. So it's already up to you. We can move it for this tutorial, but if you want to change it, of course you can change it. How to change, for example, location? You can just use the command move. Just use the command move, connect your geometry here, and here is your motion. Motion by Z direction, for example. Of course you should show which direction you want to move, and only after that you can write, for example, 1600 millimeter and connect it to the Z direction. And as you can see, direction was changed. This is previous one, this is new one. And here it was changed to the green one, it's new position. And as you can see, it's somewhere here, it's now our middle point. And as you can see, it's much better on this side. And now we are covering everything. But as I said, it's already up to you. If you want to change, but now you know how to change it. Let's leave it like that. It's pretty nice for us. And now I wanna get offset. As I said, I wanna offset my geometry. Let's use the command offset. Here is the offset, and we wanna use the offset surface. Let's connect our geometry to the surface. Let me will hide everything what I don't need. Now you can see the previous geometry, and here's the new geometry. And here the distance. For example, I want to offset to 1800 millimeters. So this is the thickness of my wall. And as you can see, we get the thickness between two objects. Actually, this is a trick. It's not the thickness between two objects. It's two objects. It's one object, it's the second one. And now we somehow should create the empty, we should making a hole inside. So we should making empty inside. And this is a really big problem, because we cannot just use the difference between two objects, between two closed objects. We should cut it, and only after that we can create the difference. Let me show you how I will use. This is not so much right way, but maybe you will find another way. Now we need to deconstruct our P line. So how we can do that? Actually, we can use, for example, P deconstruct. Here we need only the Z direction. Let me connect our point to the point, and now we can get Z direction. But the problem is we will get, as you can see, 2 times numbers. This is not for us. Let me first, I will make the flatten. Now as you can see, everything in one list, and now we will take only the one number. We need only the one number. Let me, I will connect Z to the list and index to the here. And as you can see, now it's here only the one number. Now we can easily create our plane. Let me, I will use the plane surface. As you can see, it's here. For the plane surface, we need our plane, but we need to show it as this is Z direction, unit Z. and our number going to the unit Z, I mean the axis Z, and to the P. Now we get our P direction. Let me, I will show you in 3D, because everything better to showing in 3D. Now you cannot see here anything, because our plane is really small, you cannot see it here. But next, what we need, where is that? PXS, plane through the surface. Okay, so plane connect to the plane. Our shape, it will be our shape of, where is the offset? It's here. Our shape, it will be like a boundary, as you can see now for our plane. And the index, we will leave it as it is. So we did it. So now we have the plane, and now we can just extrude it and delete what we don't need it. And as I said, extruded, we need extrusion. Here is the extrusion, it's here. We will connect our surface to the here, and we need again direction. We can again the Z direction, let's connect it. And we need some number, let me say 25 meter. 25 meter. And as you can see, now we can extrude one form from another form. Okay, we did it. Let me see, it's on the middle side or no, because as you remember, we changed the position. We should move it. Where is our move? Our move is here, as you can see. We should move this too. Let me, I will use the move. I will connect here geometry and distance, it will be the same. Yeah, and as you can see, we moved our geometry too. Let me, I will unhide everything what I no need to see it. Okay, and now we can see only the internal geometry, external geometry, and our future geometry, which is will use like difference. Let's use the difference. Here is our difference. We will use solid difference. Our main object, let's start from the internal one. External one. Our main object, and our secondary object is this one. Now let me, I will unhide, hide our external geometry, and let's hide our cube. And as you can see, we cut it. But we cut it, but only on the middle side. We not cut it in internal side. So I mean, we not have the this is like a smooth corner inside. How we can do that? We need again use difference. Let's use difference, solid one. This is our main geometry. Let's connect it, and here is our internal geometry. Let's connect it as a second one. Now we don't need to see the shape of the internal geometry, and we now wanna see the previous one. Play off. And as you can see, we get this is form. Now we need just mirror it, and that's it. We're done. What we gonna get in Revit? As you can see, it's here. We get half of our form. If you enough for that, you can leave it as it is. But we are not finished. Let me go back. So this is a main form. Yeah, it's really hard to understand because it's really a lot of the different things. But I think this is much easiest for the new users in Rhino. Then you will use some hard shapes. Okay, let me, I will mirror it. Double click. Let me use the mirror. It's here. Let's connect our mirror geometry to here, and as you can see, mirror we get on this side, but we should change it. I mean the position, change it. Where is our mirror? And we can mirror by Z direction. How I know it? Let me, I will use this Z direction, and let's connect just to the plane. And as you can see, we mirror exactly as we want. And as I said, here is the plane. We can now just easily connect our surface, PXS, where is our PXS is our surface, to the move. Let me, I will use the move. We don't need this one. Let me, I will connect this PXS to the geometry. As you can see, here it is. And let me, I will connect X, Y, Z direction here. And as you can see, exactly it's on the middle side. And now this geometry I will connect to the P. I will hide it, and as you can see, we get our shape. It's exactly on the middle. So this is one part, and this is another part. As you can see, it's really simple. Now you can, of course, make the union if you want. So let's use the union. I will use the solid union, and let's create like one geometry. right click, preview off, right click, preview off, and oh, we need to connect another geometry because here is only one part. Here is another part. Let me will connect it. Just use the shift key and you can connect it in the same node. And now you get one union object. If you will go back to the Revit, you can see here is the one union object. And now we can easily, for example, bake this geometry, which is we will get in Rhino, as you can see it here. Or the another way, we can transfer it to the Revit directly. How we can do that? I will delete everything I don't need it. We can use direct shape. Let me use direct shape. Here's the direct shape. Here you can change the name, category, and material. We did it already last time. And now we can just connect our geometry result to the geometry. Let me, I will make the flatten. I will show you why. Go to the parameters. Again, we need this table, and as you can see, we get it two closed wrap. Actually, we need only one. What we will do again, we will go to the list, where is our sets, list item, I will connect to the list. And before we will connect to geometry, we need to choose, for example, the index 1. And let's connect it to geometry. Let's wait it, let's go back to the Revit, and what you can see, here is our geometry. So guys, in this tutorial we covered really all these things, a lot of different things. For example, how to connect how to find, for example, our geometry from the Revit, how to connect and find the midpoints, how to use the midpoints, how we move it, how to use different solids, everything. We really covered a lot of the really things. Of course, we can create in Rhino our shape, we can transfer it to the Revit and manually change, for example, position in Revit. We can do that, but I'm trying to show you how the Rhino can change your life. Once you create this script, yeah, it's really hard to understand when you're working the first time, but once you will create it, for example, if you will get changes, for example, of size, let's say this egg, you will change the size, or your client wanna make it a bit thicker or maybe a bit bigger, why not? You can change it easily just by these sliders. This is the reason why the Rhino.Inside really can help you. But for today, tutorial is finished. Thank you guys for watching and see you next time.